Okay. So the detailed things are, I mean, like again, there's enough and more documentation. Like what this chart is about, what it does, how to configure every aspect of it, what each of the flag will do, right? So you will get pretty much all the things that you need. Yeah.
Nitin, to enable Prometheus in our microservices, we have to add some dependency, right, in POM.
Repeat, it was stuck, though. Hello.
Yeah, to add Prometheus, we have to add some dependency in POM, right, to enable Prometheus in our microservices.
Right, but again, at this point, we are not really doing covering those things. Okay, so that will be, you will add an actuator endpoint, so Spring Boot actuator will enable. Um,
Mm-hmm.
Actually, with the newer version, I think that's all you need. In fact, if you go to slash metrics endpoint, then with actuator, you will get the Prometheus exported metrics.
Mm-hmm.
Now, what Prometheus? So this will be a Prometheus that will be set up in the cluster. Okay, so then what you scrape, right? Then
Mm-hmm.
the applications will have to be instrumented so that they export some metrics. Then you will consume those metrics with Prometheus, and you can showcase them in the dashboards and stuff. Okay, but again, it depends. Like uh, there will be a trade-off because if you are scraping metrics from all those dashboards, I mean all those microservices, then you also need a lot more memory to query reports and all of those.
Mm-hmm.
So as of now, we don't do that, but again, we can always do that and show you how we'll have to add and how we
So currently, how is Prometheus fetching data?
can. Yeah, and I'll detail.
Okay.
Let me just see what's coming, what's not. Okay, all right. So this is the Helm chart for the Prometheus thing. Okay, and then you have all the details you need of what each of these thing do, like each flag, what it does. You have it in the README. Okay, so you can go through the README and you will get to know as to what each one of those parameters mean and when do you enable, when do you not enable it. All of that you will get it from there. Okay. So having said that, I'll just try and give you an overview of what changes we have done. What are the things that are most important out of these many variables and stuff, right? Uh, First and foremost, what we do is once the Prometheus, so Prometheus operator, what Prometheus operator does is you will be defining Prometheus operator that you need this kind of Prometheus. You need a Prometheus instance, you need an alert manager instance. Now, actually creating those pods and maintaining the deployment and all of that, the Prometheus operator takes care of it. So you will never create a deployment for Prometheus and a deployment for Alert Manager. Rather, you will create a deployment for Prometheus operator and you will tell Prometheus operator that I need a Prometheus instance and I need a Grafana instance with these many replicas, and it will take care of maintaining that and the manifest and all of that. Okay, that is how operators work. That is what is an operator in Kubernetes or Helm terms. Okay. Now, okay. So, like I said, we will create the deployment for Prometheus operator. Now, this Prometheus, other Prometheus, we will never create. It will all be automatically created. Same thing with the alert manager. We will not create alert manager deployment. The Prometheus operator will create the alert manager and maintain it automatically. Uh, when you create Prometheus, it will create a bunch of CRDS, which means custom resource definitions. Okay. So in that, what does that mean is you can now do kubectl get something like Prometheus hyphen and monitoring. Okay, so there's no access, but then what it does is you can list out the Prometheus as a like how you do kubectl get deployment, right? Now kubectl get Prometheus is also a command. That is because of your CRDS. Because you've defined a custom resource definition which says when you do Prometheus, you showcase this kind of data. That is what CRDSs mean. Okay, so and there are a bunch of lot of manifests that are created by whenever you try to deploy this. A lot of exporters, a lot of basically there's a bunch of things that get created whenever you try and deploy Prometheus. Uh, Once the Prometheus instance itself is startup, right? So after that instance is startup, you have a few things. What you define is you will define rules. Those rules will be evaluated at a specific interval that you specify. As and when those rules are being executed, it will find then if you configured an alert manager instance, the alert manager instance will then query the Prometheus server often to check has there any rules that has been violated, and if those rules are firing, alert manager will then check, okay, if this rule is firing, then should I do something? If there is a configuration, it will send out the alerts. Okay, that is the overall working of the alerting and the rules and the Prometheus, like the entire, that is how these things work. So Prometheus is the main instance, and its sole job is to query the configured exporters. Now, exporters are the pods or the containers which will export metric informations about a service. It could be exporter can be something like a Spring Boot app in which when you go to slash metrics, it will export metrics for that application. Maybe how many requests are coming in, what is the memory usage currently, what is the heap usage. Now that is, you can call that Spring Boot app as an exporter. Okay. Same thing, you can have various exporters like Kafka exporters, right? Or you can have things like HCD exporters. Yeah, let me just show you. Okay, Core DNS exporter, Cube API server, Cube proxy, Cube state metrics, Kubelet, Node exporters, right? And there is one more custom thing that we have created called Prometheus Kafka exporter, right? So there are many sort of exporters. Now the job of exporters is when you hit a URL, it will export the metrics at that point of time. What are the metrics? Maybe how many times a certain API is called, how many times or the absolute values, like at this point of time, what is the memory usage, what is the CPU usage. That is the job of the exporter, right? What Prometheus will do is it will scrape the endpoints exposed by these exporters. Okay, it will get data, it will save that data according to to the respective timestamp. Now if it is doing a query at 12:19, it says 12:19 p.m. I queried this exporter and the values are this. It will maintain that. Now that is the job of Prometheus. After that, it will have rules. You would have set up rules which says for a period of 5 minutes, if the memory usage is very high, you fire the rule has to fire a alert kind of thing. Now what happens then is if for a certain thing you've configured rules said that over a period of 5 minutes, if the CPU usage is more than one CPU, please fire an alert. So that alert would be fired. That is the job of Prometheus. That ends the job. That is the all Prometheus will do. Now the next, how to report this alert is alert manager will ping this Prometheus instance, check if there are any active rules that are firing. If there are rules firing, and if there is a config for that firing rule, it will dispatch a either a Slack message or an email or something of that sort. Now Grafana also will query the same Prometheus server to display the dashboard in a more nicer way. It will display those numbers. Okay, so this is the overall setup of Prometheus, of what's happening in the entire Prometheus monitoring system. There's nothing else. This is all that's happened. And it's a constantly happening cycle. It just keeps happening on and on. So any questions on this?
Yeah, that you explained the rules now. If you want to add any rules
Yeah,
like
we'll
memory
come there.
uses.
So about the overall working of Prometheus, that is clear.
Yeah, yeah, yeah. It's clear.
Okay. Right. So then let's go to the other things, right? So how do you write rules? Okay, so that is the question. So that I'll show you. So these are various rules that are actually already written some by people or something we've added and those kind of things. So if you can go through each of those rules, of course you'll have to learn a new language for this called PromQL. Okay. Uh, what this does is you will first write an expression here. Now the expression it says uh, what it does for a certain things. Like at this point of time, what it does and when I have to fire a switch. Let me take a easier example. Let's see storage. Huh? Okay, let's see storage. Now this is one thing which says Q persistent volume is filling up. Now here what happens is so you've written you need to write an expression then which says you will first have to go check what metrics are available. So you can go to each of those exporters like kubelet exporter or any of the exporters. Right? Kubelet. Okay, but a bit more difficult to find it. But whenever you go and see, you will get a detailed listing of what are the types of metrics that are exported by a certain exporter, right? Now, based on that, you need to write these expressions. This is also a time series, so you have a third dimension. So writing the queries is a little tricky. You need to write queries so that you get um meaningful rules out of them. Okay, so what this is telling is over a period of time, if the remaining left out volume usage, volume space is 30% or lesser, then you fire a rule saying that the Kubernetes persistent volume is filling up. Please do something. Okay, so you can see here. Okay, it'll do some approximations. So there are various rules across for the same thing. Like you can see that. You can see pod crash looking, right? You always see this. So what you are saying is for 15 minutes, if the pod is continually still crashing, which means for 15 minutes, if this expression validating true, okay, if this expression is coming as true for a period of 15 minutes, then it will fire an alert or a rule. The rule is then firing. Alert manager will then pick up on this rule, okay, and it will fire out the actual what it needs to do for that particular rule. Okay, this same thing will go for your dashboards as well. See, okay, so you have various things such as these expressions. Again, the expression is the same. Where what you used for the rule and this. You have things like what is the for the period of last. I mean, for a period of 10 minutes, what is the delta between the current offset? So you will get in the 10 minutes what is the addition or what is the increase in the offsets. So this will be useful in case you have a consumer group against a particular topic. Now, in this topic, a consumer group is consuming continuously. So you can get a consumption rate kind of thing as to okay for this much consumption is happening for 10 minutes. So that is how you will write the expression for this. Okay, so again, this is again another query which says how many letters or how many messages are there in a dead letter topic. So what we are doing is we are saying do a regex on the topic name which says star dot dead letter. and try and give us the current offset. That will be the max. That will give you the count across all partitions, right? And you will add it that up, and then you will show the total dead letters. So many such things. So basically, uh, how you will learn it is you just have to use this and try and learn the entire thing. But then, yeah, this is how the rules are then taken care. Okay, but as long as you are able to write a rule, what is other than that, what is there is you just have to follow this entire thing. You will write one API version kind blah 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 and this thing. What this one will give is when you do kubectl get Prometheus rule. Okay, this will automatically you will get all the Prometheus rules that are registered in the cluster. Now these Prometheus rules, because it's a Prometheus operator, it will scan for this kind, or basically instead of doing, it will watch for Prometheus rule objects. Okay, every time you deploy a new rule, what the Prometheus operator is, it keeps scanning. Okay, is there a new resource called Prometheus rule coming? Okay, there's a new resource. Now I need to edit the config file. What it then does is it will read this Prometheus rule and create a config file by adding this Prometheus rule, and it will deploy it on the existing Prometheus instance that it's maintaining. So the rule file is then updated on that Prometheus instance. Okay. So same thing goes for alert manager. So if you add a new alerting thing, what it then does is that the alert manager is you add a alerting rule. Alert manager Prometheus operator will scan that thing. It will make the config file from that object and create it. This is very similar, almost same as an ingress. When you create an ingress object, right? Nginx ingress will watch that, create the Nginx config file accordingly, and it will deploy it on that Nginx that is running. Okay, you won't manually go and edit that config file. That config file is prepared by the Nginx ingress operator. Same thing here. You won't modify the config file. Rather, you will add objects such as Prometheus rule. The Prometheus operator will then get these things and make the config file and put it in the Prometheus. That is the work of the operator. Okay. Now, apart from this, there are these rules that are configured, right? You even have things like what rules needs to be enabled, what rules need to be disabled, and stuff. You can always check them here. Okay, so there are default rules. So by default, we've switched off the node exporters. So basically, node exporters, whatever exporters are there, right? You can control what kind of exporters you want to run. Now these are these many exporters. For instance, we don't monitor core DNS or Cube API server. So you can check values that are there, which are all those exporters are disabled. Now, same thing with the rules. Now, if you're not even monitoring HCD, then what's the point of having HCD rules? So you disable those, right? So that is for the false. We only have the rules for these kind of things. Wherever true is there, those rules are actually enabled. You can always control which rules are enabled. These are defaults. You can control them based on a particular deployment. Now imagine in the dev cluster you don't want it, or maybe in the SDC cluster you want to monitor things like HCD, Cube API server, Cube nodes, and all of those, right? In that case, you can set all these to true so that even those things start to get monitored. Again, the entire all of these in detail is covered in the readme.md. You can always go through that link and more detail. Okay, you can see that now what rules needs to be created. If you set it to true, this happens. If you set it to false, this happens. Okay. Okay, more questions anymore? So I think the large part of this is learning about Prometheus from QL itself. Okay, the rest of it is still fine, but from QL and the entire Kibana syntax and stuff, those are something that we'll have to spend time and learn how to write those queries. Like for instance, all these are like written custom dashboards. Right? There is entire consumer dashboard and stuff. So you need to learn how to write queries for your particular use case, and you will write the relevant things. Right? Even here, a lot of the CPU metrics and stuff. How do you get? So all of those you need to write those according to your use case. Of course, you will get default dashboard for some. When you get, you can just copy those queries. But whenever you need for your particular use case, you need a different thing. You'll need to write so that you know that what is the CPU being used, what is the memory being used.
So where is this data stored, Nitin? This whatever data is getting streamed, right? It's stored in Elasticsearch.
No, 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 no. So Prometheus things will always get stored in the same Prometheus itself.
No,
Prometheus has its own storage. Okay. Uh,
separate volume is loaded.
Within the pod, it will have a persistent volume, and you
Mhm.
can have a persistent volume and store it. But what we do is we have a inbuilt temp directory wala storage. Basically, if the pod shuts down, we lose the data.
Okay.
I
Okay.
think that is a balance. Like if you want to have an external storage, you can do that. There are other things you can integrate with things like time series DBs as well. There are several of them, influx DB and stuff. So if you want to deploy an influx DB instead, you can
Mhm.
deploy it, which is can then connect to that.
So
Okay.
like ours never got full or what means. So
Yeah. So what we do is we have a retention period of just 2 days. Okay.
okay.
And every 2 days it will clean up those metrics.
Okay.
Okay.
Fine. Okay.
Again, you need to figure out what is the best for your use case. Maybe production use case, you will want to allocate more of those. You want to
Mhm.
have more such selecting. And so now you saw that we've set a lot of these things to false, right? So I showed you the values that YAML saying we don't need these, we have set false.
Mhm.
Not
Yeah.
these rules, but even this exporter. So we don't even export data from things like ODNS, Cube API server, all of that. Now the reason
Mhm.
is we want to limit the number of sort of metrics that are stored, and so that memory also usage is less. So that's the reason we do that, so that memory and storage is lesser.
Okay. So this PromQL operates on its own persistent volume, is it right?
Correct. It goes
Oh,
to PromQL. When you write a PromQL, you will hit the Prometheus server. Now that
mm,
Prometheus server will then internally query the data that it stored. Now that is that Prom database itself. They only have made their own database, and they're maintaining it.
okay.
Use some kind of RocksDB and all of that as well in the backend. But again, it can also connect to InfluxDB, but then you have to create and maintain that database again.
Adapter again will need for that.
The adapter is all there, so everything is
Already
you can configure instead of using this, use InfluxDB, provide the URL, it automatically works. But the problem is you need to then
create
have
an
to maintain the
application.
InfluxDB. That InfluxDB instance you separately have to manage it.
So here this Roxy DB is inside of this pod only Prometheus, right?
Yeah.
Okay. So it doesn't have integration with Elasticsearch or something which is like
No, no. So
already.
Prometheus does not have integration with Elasticsearch. It can only do writes to it, so it cannot read from it. So it can
Okay.
deposit data into it, but it cannot read because it's a time series database, right? So the entire paradigm itself is different. You have another dimension that Elasticsearch is difficult to work with as of now.
So if we dump data on Elasticsearch, then we can use Grafana to display it, right?
You can use Kibana, yeah. You can use Kibana to display it, but then how effectively you will be able to do it, that you will also have to check.
Hmm.
Because a
So
lot of these things are based on only based on time. Like for the last 10 minutes, what happened? Last 5 minutes, what happened? What is
mhm.
the increasing rate of data for the last 1 hour or 1 day, and all of those, right? So Elasticsearch can usually be quite slow in all of those, or can take more memory because it's not designed to be a true time series database.
Hmm. Oh.
And you will have to write your own dashboards and this because not a lot of people support are working on that. But
Oh.
for Grafana dashboards, most of it is already there. You just have
So
to do tweaks.
Grafana works on top of this DBs only,
Correct.
right? Roxy DB. Okay. Okay.
Grafana works on Prometheus. So all of these, most of these things, what happens is it will always work to Prometheus. Now what we are doing here, now Grafana can work on Elasticsearch also,
Mhm.
but we use Grafana uses Prometheus. So Prometheus will abstract what is there underneath. So it is
Okay.
uh, whether you are connecting to, even if you connect Prometheus to InfluxDB, for instance, right? Because InfluxDB both read write are supported. If you connect that to InfluxDB, you will not know, Grafana will not know whether it's connecting behind to RocksDB, InfluxDB. It will still continue to work because
So
API
it
is
doesn't.
Prometheus.
So those rule configs are loaded inside of Prometheus pod only, right? So we have three pods, right? Alert manager is one, and Prometheus operator is one, and Prometheus is one.
Yeah, so whenever you deploy those rules, right, it will be like an ingress. You will deploy that ingress or a Prometheus rule.
Mm-hmm.
Rules are read by the Prometheus operator.
Okay. Okay.
Okay. And what that will do is it will assemble based on the rules, based on the configs and everything, it will assemble the config file.
Mm-hmm.
Like how we do for Zool, right? We'll get
Yeah.
surveys we'll do and we'll create that Zool routes config file, right?
Yeah.
Same Prometheus operator will do, it will do that config file and will
Mm-hmm.
send it to Prometheus, this pod, and say that, see, I have, created a new config. Please reload your configuration to take the new config.
Okay. So if I go inside of the pod, there I can see those rules there, right?
Correct. You can, if you check the config file, you will be able to see all the rules and everything.
Okay.
Okay. Raju, Nikesh, what else? Anything?